what we have done in the previous class. We have introduced directional derivative. So let us recall what is directional derivative. In the previous class, we discussed about, suppose if you want to compute the derivative of a function, suppose f is the function of two variables, fx and y, and suppose we want to compute its derivative in one direction, like del f over del x or del f over del y, then it gives the partial derivative or rate of change of f in the direction of x comma y, x or y. Del f over del x means the rate of change of f in the direction of x, and del f over del y, that means rate of change of f in the direction of y. Okay, but in a space there exist more than one these two directions. There are not many direction, or we can say infinitely many directions. Suppose there is some point x naught, y naught, and there doesn't exist only these two directions. There exist more directions also, like not many directions. So in that case, we are required to introduce directional derivative. So what is directional derivative? Suppose x and y, f is the function of x comma y, and x and y are associated with some variable s. Okay, fs or gs. Suppose f is the function of x comma y, that means we can write it in this way: x, y, and x and y are denoted by some function fs or gs.
Ma'am, can you please repeat? I just joined now.
Yeah. So whatever we have done in the previous class, that we are recalling. So I told like f is the function of two variable, and the partial derivative of the function gives the rate of change of the function in respective direction. Suppose del f over del x, that means the rate of change in x direction. Del f over del y, that means the rate of change in y direction. Let us suppose x and y are, f is the function of two variable x and y, and x and y are associated with variable s. That means they are defined by some curve s. Okay, then if we are interested to compute rate of change of f in any of the direction, like I told you, except this x and y direction, we are talking about rate of change of f in any of the direction. Like these are all different directions. Okay, suppose we are taking a particular direction, maybe here, this is the line AB, and the direction of AB is denoted by unit vector u. Okay, and u can be written as u1i plus u2j. A is a point and whose coordinate are x naught and y naught. And suppose this, maybe this is the line, and let us denote this point by B. So equation of the line AB. This is the point xb, x naught, y naught, and the equation x and y are any general point on the line. Okay, so equation of the line AB will be what? X minus A, or in vector form we are writing y minus B, x minus x naught A, y minus y naught J, equal to, suppose this is the distance. Distance between A and B is S. Okay, S into U. U is what? That is the unit vector. Okay, so x minus x naught I plus y minus y naught j equal to S u1i plus u2j. Then it can be written as, on comparing, x minus x naught equal to su1 and y minus y naught is su2. Okay. Now we are talking about rate of change of f, rate of change of f in the direction of AB, in the direction of AB. It is denoted by df over ds, because s is what? S is the distance in this direction. U naught is what? That is associated with the unit vector in this direction. Okay. And at the point A is what? That is the point x naught y. So this is what? Directional derivative, directional derivative of f in the direction of AB. In the direction of AB. Understand? So this is the directional derivative means what? Like df over ds at u naught is the unit vector in this direction, and A is what? That is the equation of the line that is the point x naught through which that particular direction is passing. We can say like AB is what? AB is the equation of the line that is having direction like u naught. We can say u cap is what? That is the unit vector in this direction. Okay, so rate of change of the function fxy in the direction of AB can be is denoted by df over ds. U hat is, it is what? Unit vector in that direction, and A is what? The point through which it is passing. Okay, after that we expressed in the previous class how we can write mathematical form of this rate of change of f in any direction. This can be denoted by u hat A equal to delta f dot u. Okay, so delta f is what? How we got this relationship? It is very simple. I will just recall here. Df over ds. I told you f is the function of two variable x comma y, and x and y are associated with s. So del f over del x, f is the function of two variable, del f over del x we can write, and it is del f over del y. And since x is the function of single variable, so we'll write dx over ds, and it is dy over ds. Okay, so df over ds can be written as del f over del x dx ds plus del f over del y dy ds. Understand? Now del f over del x, just one more thing, dx over ds. How we can compute this dx ds and dy ds? We have already computed this dx over, like we already have a relationship between x and s, that is x minus x not equal to su1. So dx over ds is what? That is your vector u1, and dy over ds is what? u2. So replace the value of dx by ds and dy ds by u1 and u2. So u1 plus del f over del y u2. It can be written as del f over del x I plus del f over del y j. We can write in vector form like this: u1 I u2 j. Okay, so del f over del x I plus del f over del y j dot u1 I plus u2 j. So this thing is what? This is your del f. This is called gradient of f. And u1 I plus u2 j is what? That is unit vector. So that's why we are writing this relationship, del f dot u. Okay, there is a dot product. Delta f is also a vector, and u is a unit vector. Understand? So this is the thing we have done in the previous class. We have done one more example. Just recall that. I'll just get this example here. Maybe directional derivative. Sorry. That I have shared with you today's class. So maybe this the thing we have done. So one example we have done in the previous class: find the derivative of the function fxy at the point 1 pi by 2 in the direction of b equal to 3i minus 4j. Okay, and direction, in which direction we have to compute directional derivative? In the direction of b. Okay, so df over ds equal to, we have to compute df ds in the direction of b and at the point 1 pi by 2. Okay, so it is equal to del f dot, I should write here unit vector u. You can write in that way also, but I'm writing it in this way. And where u equal to what? B direction upon mod of v. That means now it is a unit vector. When we will divide a vector by its modulus, that is 3i minus 4j upon modulus of the vector, that's 5. Now what we have to do, we have to compute del f dot u. So del f means what? I told you del f means what? Del f over 2x and with respect to y. So we are getting these two terms. Okay. After differentiating, now del f at 1 pi by 2, put the value of x and y as 1 and pi by 2. We are getting the value of del f at 1 and pi by 2, it is minus j. And del f dot u is this value for y. Okay, so this is the directional derivative. So this is the directional derivative of the function in the direction of b at the point a, that is what 1 pi by 2. Understand? Clear?
Can you
So
show this example again? I didn't see the question.
okay. Just a minute. Wait for 2 minutes. Actually, I have to.
Excuse me, ma'am.
Yes. बोलिए.
मेरे last example में doubt है तो बोलिए.
Just a minute. I'm doing. Wait for a minute. Actually, I'm getting a small, like, some technical problem. I'm just following you.
Ma'am, in that derivative, shouldn't be 2x square cos 2yj?
Pardon?
Ma'am, in that derivative, where you have written df by dy, over there 2x square cos 2yj.
Yes, ma'am.
You're talking about this?
Ma'am, example, yes ma'am, here
Yes.
only. Del f
Yes.
equals to del f by del x I plus del f by del y j. तो वहाँ पे 2x square cos 2y नहीं होना चाहिए.
2x square. Yes.
Yes, ma'am.
Del over del x, it will be 2x cos 2y, and del f over del y, it is x square sine 2y into minus of 2 into sine 2y. Yes. Okay. There is a mistake. It is 2x sine 2 pi by 2 I plus x square, it is minus 1. It should be minus 1 square. It is minus 1 square plus cos 2. So there is a mistake. I'll rectify in the notes. Okay.
Yes, ma'am.
Okay. So let's do another question. Again, going back to the yes. So this is the procedure to how to compute directional derivative of the function in any of the direction. Now, let us do one more example here. Let us take one more example. That is.
मैम जो आपने मिस्टेक सही कराई है वो सही है शायद. आई थिंक बिकॉज वी वर ट्रीटिंग वन एज अ कांस्टेंट, वन वेरिएबल एज अ कांस्टेंट. सो देखिए मैम, यहाँ पे x की रिस्पेक्ट में कर रहे हैं तो मैम cos y तो मैम सारा ही मतलब sin y तो सारा ही कांस्टेंट हो गया ना, तो एज इट इज लिखना पड़ेगा sin y को. तो why we are respecting?
Oh, just a minute. Whenever we are differentiating f with this, f is equal to what? X square sine 2y, na? When you are differentiating with respect to x, then
Yes,
it is
ma'am.
2x. Sorry, sine 2y remain as it is.
Yes, ma'am.
When you are differentiating with respect to y, del f over del y, then x square will remain as it is, and differentiation of, okay,
Cos 2y dot 2.
sorry,
Yes, ma'am.
x square, this is cos 2y into 2, huh? This one.
Ma'am.
Yes, ma'am.
So I think del f over del x is what? 2x sine 2y plus x square.
Sine 2y.
There should be 2 also, no?
Yes, ma'am.
Yes, ma'am.
There should be 2 also, no? So it should be 2 1 square cos 2 pi by 2. Okay, so it is coming out to be plus j, plus it is 2, it is 0 sine pi, and it is coming out to be 2 cos pi is what? Minus 1, minus j. Okay, this is minus 2j. Correct? It is 8 upon 5. Okay. Now, one more thing. Let us talk about another example. Just a minute, I just want to do another page. Where is my page? Now, one more example. When f is the function of 3 variable, okay, x, y, and z. So in that case, the same procedure, df over ds, you had in what direction you are computing. Suppose just keep in mind, whenever we are talking about direction, so u is what? That means we are talking about any direction, then it is a vector. And at the point a, p, whatever, in the book generally it is represented by p naught. P naught means what? The point x naught and y naught. And whenever we are writing this value, then we are writing here unit vector. So just keep in mind, so there is a difference between this and this term. Okay, iska matlab kya hai? We are talking about a particular direction. Okay, and it means what? We have, whenever we have to compute directional derivative, then we have to do dot product with u hat. Okay, so let us suppose, so this is what? In this case, del f will be what? In this case, del f will be del f over del x I plus del f over del y j plus del f over del z k. And u hat will be what? It will be u1 I, u2 j plus u3 k. I, j, k are the unit vector in respective direction like x, y, and z. Okay. One more example we are doing. Find the directional derivative of the function. Find the directional derivative of the function fxy equal to x e raised to a y plus cos xy at the point 2, 0 in the direction of a. A is equal to what? 3i minus 4j. Find the directional derivative of the function at the point 2, 0 in the direction of a. A is what? 3i minus 4j. So it is also same, by the same procedure we can do it. Like, let us do it fast. So direction u is what? In this case, u will be a upon mod of a. ठीक है ना? So 3i minus 4j upon 9 plus 16, it is 3i minus 4j upon 5. And delta f equal to what? Del over del x e raised to a y plus cos xy I plus del over del y x e raised to a y plus cos xy j. Okay, so it is e raised to a y plus sine xy into differentiation of xy is y I, and differentiation of this x e raised to a y minus sine xy into differentiation of xy with respect to y, it is x. Okay, so this is delta f. So del f at the point 2, 0, it will be e raised to power 0 minus plus minus sine 2 into 0. It will be whole 0 actually. I plus x2 e raised to power 0 minus sine 0 x equal to 2. J. Okay, so it is I plus 2j.
Yes.
Okay, so df over ds at the point 2, 0, like in the direction of a 2, 0 is equal to I plus 2j dot 3i minus 4j upon 5. Okay, 3 minus 8 upon 5 minus 5 upon 5, it is minus 1. Okay, so this is the question we have done. It is a simple question. One more question that is given in the notes, you can try by yourself later on. One more thing, let us discuss about the properties of the directional derivative. Properties of the directional derivative. Properties of the directional derivatives. So df over ds, we are writing as in the direction of u at the point A, delta f dot u. U is what? That is a unit vector. So this can be written as by the property dot product of the vector A dot B. If A and B are two vectors, then it can be written as mod of A, mod of B, cos theta. Cos theta is what? It is the angle between the vector A and B. Okay. So it can be written as mod of delta F. Delta F is what? It is also a vector. Okay. Into unit vector into cos theta. It can be written as delta F mod u hat, it is what? 1 cos theta. Okay, so delta F cos theta. So what it represents, df over ds is equivalent to df delta F cos theta. So the value of the directional derivative is maximum. Like from here, what we conclude, when this df over ds would be maximum?
Ma'am, when the angle is 90 degrees.
तब तो 0 हो जाएगा.
Angle is 0 degree.
When the angle is 0 degrees.
Sorry. 0 degree. Yeah.
Yes, is maximum, or we can say rate of change of f is maximum when theta equal to 0. Okay, or we can say cos theta equal to 1. So we can say function f, rate of change of the function f is maximum whenever theta equal to 0 or cos theta equal to 1. We can also say, just a minute, we can also say maximum rate of change occur in the direction when delta f and u is parallel. Delta f and u are parallel. We should write one parallel. ठीक है ना? So maximum rate of change occur whenever delta f and u, they are parallel. Okay. So this is the case 1. When it will be minimum?
Pi pe.
Hmm?
Ma'am,
Opposite direction.
Rate of change will be
no,
minimum whenever theta
when
is
angle is 180 degree.
180 degree. Yes. So df ds, or we can say rate of change is minimum whenever theta equal to 180 degree or pi. Okay, so what will be the value? We can say df ds in this case equal to minus del f. That means cos pi equal to -1. Okay. So we are just putting the value here. Here df ds इस केस में क्या होना चाहिए था df और df ds equal to okay third no
मैम
change
ये क्या लिखा है आपने डेल्टा एफ के साथ?
where
मैम डेल्टा एफ एंड यू वेक्टर आर पैरेलल.
हाँ delta f and u are parallel. They are, in this case delta f and u are parallel but they are in opposite direction. So here suppose this is delta f and then u, they are in opposite direction. In this case both are in the same direction. Okay, suppose we are talking about delta f and u. Okay, and now no change occur when theta equal to pi by
90 degree.
that means df over ds equal to 0. Okay, and cos of pi by 2 equal to what? It is 0. So these are the property of directional derivative. So maximum rate of change occur whenever cos theta, like angle between the vector del f and u, is equal to 0. Minimum change occur whenever angle between them is pi, and no change occur whenever theta equal to pi by 2. That means delta f, suppose this is delta f and u, they are perpendicular to each other. Okay. Okay, so we can also express this in this way. This is x-axis, y-axis. Suppose this is delta f. Suppose this is the point A. So this is the direction of maximum change, direction of minimum change, and this is the direction of no change. One more thing you should keep in mind, like this direction. This is perpendicular to this. So this is also the direction where no change occur. Okay? Both are perpendicular. Because when delta f and u are perpendicular to each other, then in the opposite direction also, suppose this is u, then also it is 90 degree. So we can also write in this way. Direction derivative in like sometime it is also we can write it in this way also, like directional derivative increases rapidly when theta directional derivative
And show the that diagram once again.
Yeah, should I explain it?
Yes, ma'am, just once.
Yeah, actually this is delta whenever just delta f, whenever delta f and u, they are in the same direction. The direction of maximum change, when delta f and u are in the same direction. U are in the same direction. ठीक है ना? Are in the same direction. And suppose delta f is in this direction, delta f is in this direction, and u is in this direction. They are opposite direction. Okay. that means they are opposing to each other. Suppose this is delta f and this is u. And if delta f is in this direction, u is perpendicular to delta f, 90-degree angle. Okay, so we are taking a case whenever delta f is in this direction and then both are in the same direction of maximum change. If one is in this direction, another is in this direction, minimum change. And when they are perpendicular to each other, either in this direction or in the opposite direction, that means there is no change. Okay, so it is not a proper diagram, only like to make you understand. So you can understand it in this way. Now, directional derivative increases rapidly when theta equal to 0, directional derivative decreases rapidly when theta equal to pi. Third, no change occurred when theta equal to pi by 2. Okay, now one example we will do. Find the direction in which the function fx comma y equal to x square by 2 plus y square by 2 increases most rapidly at the point 0.11, decreases most rapidly at the point 0.11. And C part, what are the direction of zero change? What are the direction of zero change at the point at 1,1? Okay. So first and second part, very simple. First of all, what we have to do, we have to compute the value of delta f. So delta f is what? So delta f is what? Okay, del f over del x square by 2 plus y square by 2, I plus del f over del y, x square by 2 plus y square by 2, j. Okay, it is what? 2x xi plus yj. ठीक है ना, x square by 2 का differentiation 2x upon 2 plus differentiation of y square by 2 is 0, and here take it simple. So this is delta f. So it is asked in which direction. Okay, find the direction in which function increases most rapidly. So whenever it is asked to compute direction, then what we have to do, we have to compute unit vector in that direction. Okay, so let us compute first del f at 1,1. It is coming out to be I plus j. So A part, function increase most rapidly in the direction of like del f is a direction, and whenever it is asked to find out in which direction, so we have to compute unit vector in that direction. So del f upon mod of del f. Okay, so I plus j upon modulus, it is under 2. B part, function decrease most rapidly in which direction? That is minus del f upon mod of del f. ठीक है ना? तो I plus j minus upon under 2. So we have already explained here, directional derivative increases rapidly when theta equal to 0. Theta equal to 0 का मतलब क्या था? Del f. When we are talking about theta equal to pi, then minus del f. So in this direction, function increasing most rapidly in the direction of del f and decreases most rapidly in the direction of minus del f. We have already explained this. Maximum rate of change occur in the direction of del f and minimum minus of del f. No change occur in this direction. So now let us talk about C part. So what are the direction of zero change at 1, 1? So zero change means what? C part. So zero change. Zero change occur whenever u is perpendicular to del f. U is perpendicular to del f. That means this implies u dot product with del f equal to 0. ठीक है ना? U is what? That is some unit vector. Not given here, but like we are taking no change occur in the direction of u. U is what? That is a unit vector. So we can write it u1i plus u2j. Okay. And del f is, we have already computed, that is I plus j. Okay. Sorry, I plus j. And if we're talking about its unit vector, then we can compute. So what we have to do? So delta u, sorry. So delta f dot u equal to 0. So delta f is what? I plus j dot u1i plus u2j equal to 0. This implies that u1 plus u2 equal to 0 from here. This implies that u1 equal to minus u2. u1 equal to minus u2. This u is what? This is a unit vector that we are taking. Okay. It is a unit vector. So mod of u, it should be 1. Okay. So that means u1 square plus u2 square, it should be 1. ठीक है ना? So u1 square plus u2 square is also 1. Okay, now put the value of u1 equal to minus u2. Okay, now. So what we will get? We will get here 2 u1 square. If we are putting u1 equal to minus u2. So it is coming out to be 2 u2 square equal to 1. So u2 equal to 1 by under 2. Then the value of u1 will be what? It will be minus 1 by root 2. Okay, na? So in which direction, like, so the value of u is what? u1i plus u2j. So u1i is what? That is minus 1 by under 2 I plus 1 by under 2 j. Okay, so no change in the function occur whenever unit vector we are like in which direction? This is minus 1 by root 2 I plus 1 by root 2 j. Okay, one more thing I can discuss here. We have come.
Ma'am, can like,
Yes.
okay. Ma'am, like, could we put u2 equals to minus u1?
Pardon?
Could we put u2 equals to minus u1?
Yes. If we are putting u2 equal to minus u1, then u hat will be what? It will be 1 by root 2i minus 1 by root 2j. So in any of the direction. Like why? Because I told you delta f is in this direction and u is what? This is the direction. Okay, they are perpendicular with each other. And delta f is also orthogonal to this direction. So, so both the direction are possible, this one as well as this one. So that's why you are having this one or this one. If you are taking u1 equal to minus u2, then you are getting this result. If you are taking u2 equal to minus u1, then you are getting this result. Both are correct results. In both direction, there will be no change in the function fx. Understand?
मैम 1 का इक्वल पे लिया आपने
1 के equal ये this you are asking this one?
मैग्नीट्यूड यस मैम
Because what is the definition of directional derivative? Delta f directional derivative definition क्या है? Delta f dot u. U is what? That is the unit vector. in which direction we are computing directional derivative ना. आप क्या निकालते हैं? Directional derivative निकालते हैं in which direction? U, and at the point A, तो U जो है यहाँ जो होता है delta f dot U, this is a unit vector ना. That's why unit vector का modulus क्या होता है? That is 1. That's why.
Okay, ma'am.
So this should be clear how to compute direction in which no change occur in the function f. ठीक है. Yeah, so one more example, let's do here. Find the derivative of the function fxyz. Find the derivative of the function fxy x cube minus xy square minus z at 1, 1, 0 in the direction A equal to 2i minus 3j plus 6k. Okay, so this is example. In what direction? So what is given? Find the derivative of the function at the point 1, 1, 0 in the direction of A. One more thing it is asked in this example. In what direction? In what direction does f change most rapidly at P, and what are the rate of change in this direction? So first find the derivative of the function, directional derivative. So what we have to compute? First we have to compute unit vector in the direction of A. So it is A upon mod of
मैम
A.
ये जो f दे रखा है आपने ये डिपेंड नहीं कर रहा z पे.
No, it is a function of 3 variable. It is dependent. Sorry.
Okay, ma'am.
Sorry. So this is 2i minus 3j plus 6k upon 4 plus 9 plus 36. It is coming out to be 7. 2i minus 3j plus 6k. Okay, so del f, let us compute del f. That is 3x square minus y square minus y square I plus minus of 2xy j minus 1k. Okay, so del f at the point 1, 1, 0, 1, 1, 0 is equal to what? 3 minus 1 I plus minus of 2 minus k. So this is the value of, that is 2i minus 2j minus k. Okay. So what is the value of dfds? So it is simple. A at the point 1, 1, 0, it is coming out to be dot product del f dot u. I'm writing directly. If you're not able to understand, you can ask. 4 minus minus plus 6 minus 6 upon 7. It is coming out to be 4 by 7. And a dot product of this value. Dot product of this one and this one. Okay. Now next, what is asked in the question? In what direction does f change most rapidly at P? So obviously, it is asked like in which direction f change most rapidly. So we have to compute del f. So f change most rapidly in del f direction. Always we are asked, when it is asked direction, then we will compute unit vector. ठीक है ना, 2i minus 2j minus k upon, है ना, this is the value of the function, this is the value of del f, 4 plus 4 plus 1 plus 3. 2i minus 2j minus k upon 3 and decreases second part, like it is, we can say a part and b part, decreases most rapidly minus of 2i minus 2j minus k upon 3. That means minus delta f direction. Okay, so I think should be clear. Any doubt you have here, then ask. Otherwise, I will ask some question from you.
मैम 12.5 का फर्स्ट क्वेश्चन करके दिखा दो एक बार.
12.5 का first question. 12.5. 12.7. You're asking about 12.7 or 12.5?
मैम 5.
On page
12.5. This w is the function of x and y, and x, y are the function of t. Huh? This one?
Yes, ma'am.
Oh. And w is the function of x comma y, and x and y are the function of t. So what you have to do, w is given as x square plus y square, and x is given as cos t.
Yes, ma'am. X cos t, y sin t.
Then t equal to
T is
5.
equal to 5, yeah, ma'am.
So so you have to compute dw by dt. So del w over del x, dx by dt, del w over del y, dy by dt. Clear? Del w over del x is what? 2x. Dx by dt is what? Minus of cos t is what? Minus of sin t. dw over dy, del w over del y, 2y, dy by dt is cos t. ठीक है ना? So बस now put the value of x as cos t minus sin t plus 2 into y value is sin t. cos t 0 आ जाएगा इसके value तो.
ठीक है मैम, आ गया समझ. मैंने पहले वैल्यूज डाल के की थी पुट.
ठीक है. So let's finish our class here. It is already 5:10. So I will upload this lecture like within 15 or 10 minutes. Okay. And notes I have already like uploaded. Whatever I have done today, the same thing I have already uploaded. Okay.
Okay.